Hi friends, welcome to classes by Lab Doctor. In today's class, let us understand briefly about this LDL metabolism. You all know that LDL is a lipoprotein. So what is a lipoprotein? Lipoprotein is a structure which consists of both lipids as well as the protein, and this is a van, or this is a carrier which will carry the lipids like the cholesterol and the triglyceride. So now you know that cholesterol and triglyceride, they are not miscible in the blood, so they cannot be traveling on their own. They have to be carried, and they will be carried with the help of this LDL molecule. So these lipoproteins, so which are the lipoproteins? You have chylomicrons, you have your VLDL, IDL, LDL, HDL. All these are the vans, all these are the transporters. So these are the ones which are going to carry. So these lipoproteins, the main function of them is to carry the cholesterol and triglyceride and give it to the cells, so that the cells get the cholesterols and lipids and they utilize it. So this LDL, the function is that it transports the cholesterol from the liver to the peripheral tissue, and it also regulates the cholesterol synthesis, and it is an important source of cholesterol to the extrahepatic tissue. The more than half, almost 50% of this LDL is composed of this cholesterol. So this gives cholesterol to the tissue. It loads the tissue with the cholesterol. So if you have high level of LDL, you can expect that it is making the cells fat, and this can lead to inflammation, atherosclerosis. So remember, LDL is a carrier which will carry the cholesterol and give it to the cells. Suppose if it is in excess, then there is excess of overloading of this cholesterol to the cells, and that can damage the cells. That is why high level of LDL is very dangerous, and that is why it is also called as the bad cholesterol. So LDL metabolism, when I talk about LDL metabolism, we will discuss about how is the LDL formed, where is the LDL formed, how is it circulating, how it is taken up by the cells, and how it is degrading. So here we will talk about liver, because liver is the main source wherein the VLDL gets converted to IDL and LDL, and liver is also an important organ which has most of the LDL receptors. So for the uptaking of the extra LDL substances and to degrade it also, liver plays an important role. So the liver is the main organ which produces VLDL, very low density lipoprotein. This VLDL gets converted into intermediate density lipoprotein, and this intermediate density lipoprotein gets converted into low density lipoprotein. So when we talk about the metabolism of LDL, you all know that from the chylomicron, when the fats are metabolized, when the fats are broken down, they will be converted into this micelles. They will be converted into this chylomicron. So chylomicrons are nothing but these micelles which will carry the triglycerides. This chylomicron, what happens, they are broken down in the blood vessels with the help of this lipoprotein lipase, and they will be broken down into your free fatty acid, and free fatty acid is taken up by the muscles, by the tissues, by the cells, and extra free fatty acid gets stored in our adipose tissue. So this chylomicron gets broken down into a remnant that is called as the chylomicron remnant. It is a smaller particle from this chylomicron. So when this chylomicron remnant is there, it cannot be left inside the blood vessels, or it cannot be left there. It has to be cleared. So this clearing action, here comes the role of the HDL. So HDL being the good cholesterol, it will give it ApoE. This chylomicron remnant, with the help of this ApoE, which allows the entry of this chylomicron remnant into the liver, and here in the liver this will use this, and here you will see that the liver converts this into your VLDL. In the liver, this ApoB100 is very important for the generation of this VLDL. ApoB, you know that this is the main apoprotein in LDL, and in the blood, the plasma VLDL will be later converted into IDL and LDL. So this is how the whole process takes place. The chylomicrons are formed. Chylomicrons gets broken down with the help of lipoprotein lipase, releases the free fatty acids. The muscles, the tissues utilize it. The adipose tissues, the extra free fatty acids are stored. The chylomicron remnants with the help of HDL enter the liver, and in the liver, the synthesis of VLDLs take place. So this is the chylomicron remnant in the circulation. It is endocytosed into the liver, and in the liver, it produces the VLDL and leaves it in the circulation. So VLDL is converted to IDL and IDL becomes LDL. So VLDL is very much rich in triglyceride and less in cholesterol. And as it becomes LDL, you will see that the triglycerides are removed and cholesterols are added. So here you will see that here the LDL is more of cholesterol. So it is less of triglyceride, more of cholesterol. VLDL is more of triglyceride and less of cholesterol. So VLDL gets converted into IDL with the help of lipoprotein lipase, and IDL gets converted into LDL with the help of this hepatic lipase, and this cholesterol ester transport protein that helps in the transfer of this cholesterol esters. So here you can see how the VLDL gets converted to LDL. This cholesterol ester transport protein mediates the exchange of this cholesterol ester and triglyceride between the HDL and ApoB containing lipoprotein, leading to the production of this LDL. This LDL, when it crosses the normal range, is atherogenic and causes the atherosclerosis. So here you can see from the intestine how the chylomicrons are formed and the cholesterol and triglyceride which are broken down into free fatty acids, the chylomicron remnants which enter into the liver, and then this liver produces the VLDL. The VLDL gets converted into IDL and LDL, and they are used by your muscles, your heart tissues, adipose tissues, etc., through which the cholesterol and triglyceride reach these tissue cells, etc., and if it is excess, it can also start the process of atherosclerosis or atherogenesis. So now once the LDL is formed, how is it taken up by the liver and how it is degraded? So the LDL, it is mainly taken up with the help of this LDL receptor, and LDL receptor, the most common site for this LDL receptor is the liver. So from here they get endocytosed with the help of this receptor. So once they get endocytosed here, the receptors leave and they come back again, and from here you will see that this LDL will once it is entered, it will be broken down, it will be internalized and then degraded in the lysosome, where the cholesterol esters are hydrolyzed. So these cholesterol esters, they can be used, suppose if it is required, then it can be used, the cholesterol can be used for cell membrane formation, hormone formation, steroid hormone formation, etc. So you can see here, this is the LDL, this is the ApoB100 which will guide here to the receptor. This is the cholesterol ester inside the LDL. It has come inside the lysosome. The receptors have left and they have again come back here, and here you can see that once it is taken here, it is broken down, and this cholesterol, whatever is there, can be used for cell membrane, steroid hormones, etc., and this is having a negative feedback or mechanism on this uptake of this LDL also. So here the same thing, these are the LDL receptor here, this is the LDL which is having protein and the cholesterol inside, which is taken by the receptors here. So there is LDL binding, there is internalization, there is lysosomal hydrolysis, and then there is regulation also for the amount of LDL which enters and the amount of cholesterol which is being produced here. So if there is certain mutation in the LDL receptors, here we can have certain issues, like for example, you can have familial hypercholesterolemia, etc., wherein if there is no proper internalization, there is no binding, etc., then it can cause problems also. So LDL receptor mutation can also be one of the causes for this increased cholesterol levels. So in this LDL, suppose if it is more than required amount or gets oxidized, then this modified LDL can also start the process of atherosclerosis, and atherogenicity increases when there is increased amount of LDL. So the clinical significance of this is that elevated LDL cholesterol is a major risk factor for atherosclerosis, because once the level increase, they can start the process of inflammation, and there can be plaque formation in the arteries. LDL subfractions also, they are atherogenic. The smaller the particles, they are more atherogenic. And LDL receptor mutations. So if there is any mutation in the LDL receptor, they also can cause increased cholesterol levels. This was in brief about LDL metabolism. Thank you so much for watching the video. Please like, share and subscribe the channel. Thank you.